Lesson 6, so now we're putting together the permutations and combinations. So remember, our first lesson was counting principle. We had 2 permutations, we had 2 combinations, and here we are to lesson 6. So it's the combination of the 2. Remember, some of the biggest things you're going to have to sort through is which one you're using and why. Okay, so here's the, I'm not going to read these 2 of these things that we've already done through our previous lessons. There's refreshing it. So your factorial notation. Remember, factorial notation, some of you guys are still looking at me cross-eyed when I draw things out, n-1, n-2 for solving. Remember, that stands for previous number. N's a general number, n-1 is previous to that general number. We don't know what that number is, and that's part of the problem. Okay? So just kind of understand that where that comes from when I draw that out when we're solving stuff like that. Remember, this right here is the repetitions. Repetitions are the A, B, C's, the stuff that's being repeated, and then here's your combination. Okay, so let's look at the first example here. So how many arrangements of the word poppies can be made under each of the following conditions with no restrictions? Now, the arrangements still have to be accounted for repetitions because an arrangement will not, like if I switch these 2 peas that are next to each other, that's the same poppies. We're not going to count that again. You never will. Okay? So we're still going to have to draw out the repetitions here. That's the point. So how many letters is it? 7. So it's going to be 7 letters, so 7 factorial over 3 factorial because there's 3 p's. Nothing else is repeated. Okay? So that number is 840. How does that change if we say, well, the first letter has to be a P? So what changes? Say that again? So there's only 6 choices now, so that's 6 factorial over 2, because we're getting a little rid of a P as well. Good. So that P just locks in for the 1 there, and then it's 6 factorial. There's 6 letters left and 2 repeated P's. Okay, good. And that gets you 360. If the first 2 letters are both P's, that simply makes it P, P, and then simply what? It's just 5 factorial because nothing else can repeat because you took the 2 P's out, so there's no more pairs. So 5 factorial, which is 120. Okay, and the last one, if all the P's are to be together, so they have to be in groups. This is one you guys keep messing up of getting kind of messages to people when they're doing their homework. Think of it as like a group, as if they have to be together, think of them as a single group that's moved around like a single number. And so what I'm saying is we know 3 P's, and then last class is why do they always start in the first one? It doesn't matter where you put them. Right. No, it's going to be 5 factorial. Okay? So there's 4 additional letters besides P's, but there's 5 spots in which we can put all this stuff. Because these P's can go at the end, they go in the middle, right? Around the I, E, O, and S. Okay? So that means you have 5 things to shuffle. So you have 5 factorial. Okay? Now, since the P's are the same letter, we don't have to worry about doing 3 factorial here because they're the same thing. Okay? If it said A, B, C need to be grouped, then we'd multiply by 3 factorial because we can shift these around when they're next to each other. Okay? So then 5 factorial, this one's 120. Any questions there? Okay, and the last one before we get to the next page. If the letter, if the first letter is P and the next one is not a P, so that would be first letter is P. What are the not P options? 4. So this is a 4 here. Okay? And so if the first letter is P and the next one's not a P, so that means that what does that look like to you in terms of what would you multiply to do this? So first letter being a P, when you say it has to be a P, it doesn't really account into your options, right? Because it's chosen. So really you kind of not picture this. The 4 here is because from there it can be one of the 4 that's not a P. And then what demonstrates this then? Say that again? Anything else? Yeah. Including the 2 P's left, yeah. What I'm trying to get to do is how many spaces are there? And how many things can it be? 5. So it's 5 factorial. You did? Yeah, sorry, I wasn't listening. Maybe I thought you said it when she said it. But do you guys see it's 4 times 5 factorial? It's 4 because depending on what letter you start with after P, there's 4 options there. So then the tree diagram idea, it's 4 times the 5 factorial of it. Yep. Because 4 is it's for 1 spot. So remember, factorials is all the way down, right? And so yeah, this is 4 for 1 spot. So it's 4 times 5 factorial. So this is Oh, sorry, 5 factorial. I did forget one spot. It's 5 factorial, but in here, we can't what? They repeat the 2p, so it's over 2 factorial. So it's 4 times 5 factorial over 2 factorial. Sorry about that. So 240. Are you saying why is it 4 times the 5 factorial? Okay, so it's 4, and the 4 is not a factorial because there's 4 possible letters that can go here into one spot. So the 4 letters that can go here is your O, your I, your E, and your S can go there. So if I put an O here, there's 5 factorial ways of doing that. If I put an I here, there's 5 factorial ways of doing that. So there's 4 options, so we times the options by 4. Yeah. Yep. Because we still don't want to repeat in here because this right here, if I put those there, and this is P1, P2, well, if I switch them, it's still the same. So we still have to take out those repetitions. So there's still spots where they could be the exact same because there's 2 of it. Okay? All right, good, good. Anything else? All right, so let's get to this one. Okay, class consists of, this is another one we've done, it's pretty good. Class consists 5 girls and 7 boys. A committee is to be formed by consisting of 2 girls and 3 boys. Determine the number of ways a teacher can choose the committee. So again, this is a combination question, right? Because we're choosing people. Their order is not important. We're choosing them. Okay? So how do we choose the girls? 5C2. How do we choose the boys? 7C3. Multiply those 2 numbers. So you get 10 times 35. There's 350 ways to choose a committee from that makeup of boys and girls. Okay, we've got a little bit of favoritism here. Johnny, the principal's son, has to be on the committee. Okay, typical, right? Politics, whatever, Johnny. Okay, so Johnny's the principal's son, has to be on the committee, so how does that change our previous? So the girls doesn't change, right? But the guys changes to 6C2, because 1 less boy and 1 less we're choosing. Okay, so that goes from 10 to 15. So 150 now, if Johnny has to be in. It's an interesting one here. There's twins, Peter and Paul. They cannot both be on the committee. Okay, so what are the options that work then? So there's an option of Peter being on, Paul being on, neither being on. Right? Those are the 3 options that meet what they're asking. So how would I do a combination for Peter to be on? Exactly, it'd be the same as the one right here. Except, nope, not quite. One little thing. Nope. So Peter's on, right? So it's kind of like the Johnny one. However, what? Right, so it's 5. So see how we have 6 choose 2 because we couldn't choose that guy. We also can't choose Paul. So he's out too. So there's only 5 choices for 2. So this is how you can figure it out. Choosing 2 here, choosing 2 here. There's 4. Wait, we need 5. Well, Peter's the 5th. We're doing 2 less boys possible because Peter and Paul are kind of both out of the equation. Peter's in, Paul's out. Okay, so that's where we're at. 5C2, 5C2. That gets you 10 and 10. So it's 100 for that piece. Well, the Paul one's the same, right? So it'd be 5C2, 5C2, so 100 here. And then the neither, what would neither be like? It's the same thing again. Okay, so it'd be, it's the same thing in terms of number, but it's 5C2 for girls, and then it'd be 5C3 for boys. Why is 5C2 and 5C3 the same? Because what's 2 plus 3? Yeah, the opposites we learned last class, right? So this is also 100. So the answer is there's 300 ways that you could have a committee that meets that requirement. Which makes sense, okay? Because pretty much we just can't have them together. Them being together is actually probably a rarity, okay? Which it is that there's only 50 ways they can be together. Does that make sense? Well, how did I get there's only 50 ways? Because remember, there's 350 total. So there's only 50 ways that Paul and Peter would be together. Say that again. Oh, 5C3? Because we're 5, because the 7 boys, we took out Paul and Peter. We need 3 of them still. These ones were 2s because Paul was in, Peter was in, so they're the 5th. Yeah. We good? Okay. This one's kind of confused the last class, so that's why I'm redoing the video. So I want to kind of set up a little better. So we'll get through it fine. It's more that the question's confusing. So I'm just going to tell you all 3 people are wrong by a little bit. And so we're going to try to figure out why they're wrong. Okay? That's how I'm going to phrase it. So David, Stephen, and Helen are trying to answer the following homework question. Students in a school band have participated in 5 popular and 6 classical music compositions for the school concert. For the school concert, they will choose a program consisting of 3 popular and 2 classical compositions. If the order of the composition matters, so the order in which they are delivered, it matters, determine the number of different programs which can be presented. Okay? So David did 11 permutation 5. Okay, so what's wrong with David's? So is there 11 songs to choose from? Do they want 5? Yeah, but what's he not? Well, he's going to give combinations that don't meet what? The 3 and the 2. Okay, so if you do 11P5, that means however many ways can I choose 5 from 11? So that means he could go 1 popular and then possibly 4 classicals, which is not what they want for the program. Okay, so he's a little bit wrong because he's not getting the right makeup. Okay, Stephen, 5P3 and 6P2. This is where it's a little bit confusing. So what they mean by the order matters is that if you have a program, right, you're going to play an order of songs. So there's going to be an order, but they don't say it. It doesn't say, and this is the tricky part from the video this morning that I'm remaking it, it doesn't say it has to be 3 then 2. This is the 3 then 2 combination. So this is saying that they have to play 3 popular then 2 classics. How many combinations of 3 2s are there? Which you don't have to do. You could go 1 1 1 1. You could mix them up, just as long as there's a total of 3 and 2. So his is wrong in the sense that he's grouping them like that we have to go 3 populars, 2 classicals in that groupings. Okay, and that's what's misleading about the question. Okay, so right here in A, just so you guys just kind of verbally I'm doing it. Okay, David's problem is he's going to get combinations that don't meet the 3 to 2. Stephen's problem is he's only going to have in 3 and 2 when he can have 1 1 1 1 for as long as he has 3 total and 2 total. So he's a little bit wrong on that. And then Helen's has 5C3, 5C2. So what's wrong with Helen's? So it says Helen correctly determines the number of selections possible, but does not arrange them in order. So she's telling you how many selections are possible, which is good. That's actually right. That's what Stephen's missing, but not how many possible. Okay? You guys are... nope, we're supposed to multiply them. Helen's is the closest to being right, actually. Stephen's and Helen's? No, but good idea. We're going to, the next part, we're going to do it. Okay, so let me say it one more time. His is wrong because he's going to get orders that don't meet 3 to 2. Stephen's is wrong because Stephen's only going to have them in 3 and 2 formations, which is not required. Okay? Helen's is wrong because she is only going to have the number of selections possible, does not have them in order. So she's just telling you how many ways you can have a 3, how many groups of 2 you can have, but not the order as well. Okay? We need a combination of Stephen and Helen's. So let's get to the next page just to finish this notes, and I'll show you what the correct way is. So Helen was on the right track. So we are going to do 5C3, and we are going to do 6C2, because this gives us the number of ways we can arrange those. Okay? How many groups of those we can get? And here's the tricky part. Okay? How many songs are they going to play? Right? 5. Well, we grab 3 and we grab 2, we want to go 5 factorial to times that to figure out the ways we can arrange them. So we pick the groups of the class, or the popular, is that how you say it? And then pick the groups of the classical, and then 5 factorial is the way we can arrange those in a group of 5 with 3 to 2 as our ratio of those songs. Okay? So how many ways can we pick 3? How many ways can we pick 2? And then 5 factorial, how many ways we can mix those up. Okay? All right, so we'll stop there. That's the first one. It's nice, short, and sweet.